Autonomous Vehicles by Alexandra Shaw. First, we are going to look at what is automation. Automation is technology that actively selects data, transforms information, makes decisions, or controls processes. With automation, we have the potential to extend human performance. The relationship between people and automation can either be strong or poor. Poor relationships can be costly and catastrophic. Strong relationships have the potential to reach superior performance. Sophisticated automation could be considered as autonomous vehicles. There are several different levels of automation. In the next slide, we are going to look at the different degrees. Levels of automation. A taxonomy developed by Ensley and Gapper. The first level being manual control. Manual control is when the human performs all tasks. This includes monitoring the system, generating a variety of options, selecting the option to perform, and then implementing the action. Level 2 is action support. Action support is when the system helps the human with a specific action. Level 2, batch processing. Batch processing is when the human selects the systems to be performed, but the system carries out the task automatically. An example of this would be cruise control in any modern-day vehicle. Level 4 is shared control. Shared control is when both the human and system work hand in hand in developing decision options. The human still ultimately makes the decision. The two work together in carrying out the task. Level 5 is decision support. Decision support is when the system generates a bunch of decisions that the human can then select. Once the human selects the task, the computer carries out the task. Level 6 is blended decision making. The computer generates a bunch of decision options and only carries out the selected option if the human consents. Level 7 is rigid system. The system creates a limited set of options to the human. The human has no control over the creation of these options. They select from the set and the system carries out the task. Level 8 is automated decision-making. The decision-making process is completely automated. The system selects the best option and then carries out the task. Level 9 is supervisory control. The system generates options, selects the option, and then carries out the task. The human's main goal is to monitor the system. The human only intervenes if necessary. This is expected when dealing with high levels of automation. The last level is full automation. The system carries out all actions. The human is completely out of the loop and cannot intervene. The human's ability is not seen as necessary. In the next couple decades, this is what autonomous vehicles will reach. What is an autonomous vehicle? An autonomous vehicle is a car that can make it from point A to point B without any manual input from the driver. The vehicle uses a combination of cameras, radar systems, sensors, and GPS to determine the surrounding area. Area in this context is talking about the surrounding cars, environment, traffic signals, and pedestrians. Artificial intelligence will be used to determine the quickest, safest route to the destination. The history of autonomous cars. Autonomous vehicles seem like the newest, greatest initiative, but in fact were first developed decades ago. General Motors developed an autonomous vehicle that was called the General Motors Futurama in the 1940s. In the 1950s, General Motors and Ford created prototypes for autonomous vehicles. From the 1960s to the 1980s, there has been several independent attempts from Japan, Europe, and the US in building an autonomous vehicle. The first attempts started with very basic forms of automation, what we would consider a semi-autonomous vehicle. These early models were tested in ideal situations, but were never given real-world application. Nowadays, we are looking at Tesla, Waymo by Google, and Uber for autonomous vehicles. Tesla is the leading company in automation. There are several advantages to autonomous vehicles. They save lives, they save gasoline, they influence the traffic patterns, they increase consumer productivity, they are a boost to the economy, and they can be applied to military. The end result for autonomous vehicles is that they ultimately will make fewer mistakes than the average human driver. The first advantage is lives saved. Most accidents are caused by driver error or mechanical failure. 30,000 to 40,000 people are killed each year in the United States due to road accidents. Driver errors can occur for multiple different reasons: lack of road knowledge, traffic violations, distractions, or driver incapacity. An autonomous car is projected to be more aware, more capable, and consistent with driving ability, and interprets its surrounding more accurately. This in turn will lead to fewer accidents. The next advantage is gasoline saved. Cruise control is a feature in almost all cars today. Cruise control is said to help cars save gas because you are entering a set speed. Therefore, your car is able to determine the load size and drive more efficiently. This places less work on the engine and adaptive ability. An autonomous vehicle will take cruise control to the next level. They will be able to anticipate the load size and will make adjustments accordingly. With the advancement of autonomy, there is also an advancement in making cars more fuel efficient. Researchers project that we could be driving cars that help us reach 75 miles per gallon. The vehicle-to-vehicle communication will also help in saving gas, with cars having a greater understanding of road and traffic conditions. They could also potentially tell the load size of another surrounding vehicle. Another advantage is traffic patterns. With vehicle-to-vehicle communication, cars should be able to tell the position of surrounding cars, creating a much more efficient traffic flow. Autonomous cars should be able to reroute to avoid traffic jams, but should also altogether be help in eliminating traffic jams. With car-to-car communication, this could help in communicating while going through intersections, allowing cars to travel faster and closer together. Consumer productivity will also increase. If there is less time spent on the road in heavy traffic conditions, the passengers will have much more of a chance to spend outside of the vehicle. Once autonomy reaches its full potential, the passengers will also be able to free up time spent in the car, allowing them to read, watch TV, work, or converse while the car drives itself. With the increasement of consumer productivity, we also have a boost to the economy. When we spend more time watching TV, YouTube, or spending our time on any multimedia outlet, we are more likely to buy things. Autonomous cars may create a boost in online shopping. Billboards will increase significantly because of this. The autonomous vehicles are also projected to be able to speak to us, alerting us when a 5-star restaurant is nearby or a sale at the local supermarket is going on. The last advantage is the military. We already see the use of unmanned air vehicles today. With the use of autonomous cars, we could also see a rise in ground warfare. With the advantages of automation, there are also obstacles in adopting. Consumer acceptance. Autonomous vehicles bring up a huge debate of trust in automation. Why should humans put their lives at the risk of a robot? Many consumers look at semi-autonomous cars and see their failures and make quick assumptions that all autonomous cars will act in this way. Many people are afraid of the capabilities of the vehicle once it reaches full autonomy. Once we reach full autonomy, we may get to a point where all cars on the road need to be partially autonomous. This could be mandated by law in order to decrease the manual driver liabilities on the road. Autonomous cars are said to be able to run perfectly as long as not interfered with a human. Human-to-vehicle interaction can negatively impact vehicle-to-vehicle interaction. Trust in automation. In order for consumers to have a strong relationship of trust with automation, the performance, process, and purpose has to be understood by the human. Performance looks at the competency and reliability of the product. It's a direct observation of the system's behavior. Process looks at the dependability and openness. It's an understanding of the underlying mechanisms. Purpose is the concern, the intended use of the system. The consumer should be able to look at the automation and answer, what does the automation do? How does the automation operate? And why was the automation developed? This in turn will help create a more trusting relationship with automation. Cost. In order to get early adopters on board, the cost of vehicles will have to come down. In order for consumers to slowly start accepting the idea, we should only increase car costs at a maximum of $5,000. 37% respondents said that they would purchase an autonomous vehicle. Once they were told it could potentially cost them $3,000, that percentage dropped to 20%. This autonomous vehicle would also take a different fuel premium that consumers seem to already be upset about. The vehicle change would ultimately be better and more efficient in the long run, but with the new mandated safety and consumer demanded systems, the new fuel technologies could alone add an additional $5,000. This is not including the autonomous systems. That is a $10,000 increase in autonomous vehicles. There are several technology hurdles that need to be solved before vehicles reach their full level of autonomy. None of these challenges are seen as unachievable. Some believe that if cost was not a variable, full autonomous vehicles would be on the road today. Some of these key technology issues are: how does an autonomous car handle weather conditions when radar sensor capabilities are rendered ineffective? How do we manage LiDAR systems for real-time changes in roadside profiles? How do we make sure the car's radar systems is continually aware of its evolving and updating environment? How do we integrate these radars and sensors into the vehicle without dramatically changing the look and feel of the car? Another key issue is how to handle the human-to-machine interface. This will greatly affect the interaction with the vehicle. How will the human know when to take over in emergency situations? The last technology issue is the struggle of getting enough autonomous cars on the road safely. How do we integrate the early adopters into a system that is still human-to-vehicle interaction? Many believe that autonomous cars are more likely to advance than full electronic vehicles. The biggest obstacles are not the ones listed here, but the others discussed. These technology flaws can be fixed. The only concern currently is the cost behind it all. Liability. The liability factor is the biggest concern, because this factors in the safety of the passenger, the company creating the car, and the surrounding people on and off the road. If there is an accident with an autonomous vehicle, who is liable for the consequences and cost? The insurance industry needs to lay down a strict set of rules at who is at fault in the case of an accident. This will contain many factors, but it is important in the advancement of technology. If a feature of the autonomous car cannot be relied upon, how do we put a human at fault for a car error? Is a human at fault just because they're behind the wheel of the car? Legislation. National and state governments will need to develop laws allowing autonomous cars to drive on the road. One of the potential problems of not creating legislation is if somebody who is not allowed or able to drive a vehicle could get in a car, the car could technically just drive itself. The car could also take off with no occupants in it. There is also a huge concern with all the private data that will be generated. This leads into later discussed the security of the autonomous vehicle. Existing car park. With autonomous vehicles, Autonomous vehicles will be most effective when all surrounding vehicles have the same capability. They will then all run under a traffic management system and drive predictable reactions to different driving scenarios. With over 250 million cars on the road in the United States, it could take decades to get only autonomous vehicles on the road. With the mixing of autonomous vehicles and manual vehicles on the road, it could dramatically decrease the efficiency and productivity of the autonomous car, leading to unpredictable outcomes and a decrease in safety. This will then lead to limited acceptance. Autonomous cars are created by humans. Humans are considered an imperfect species. With that, that means that the automation developed by the human is going to be an imperfect system, meaning that it is important to only have autonomous cars on the road at one time so the automation can communicate with one another rather than the automation communicating with the human. The infrastructure. With autonomous vehicles, we will not make much of a change in the already established infrastructure, but we will need new road markings, signage, GPS mapping, strong telecommunication networks, and ideally some level of vehicle-to-grid communication. Security. The question of how can an autonomous car be hacked arises. Researchers believe that autonomous cars are most likely not as vulnerable as one may think. Hacking a car wirelessly is much more difficult. The auto industry is aware that once the software is established, it may become much easier, but is working on how to prevent that. Two ethical issues arise. Can we program an autonomous car to respond to every single conceivable scenario on the road, including instances when it may be necessary to break or circumvent existing laws or rules to achieve a favorable outcome? An example of this is going faster to get to the ER, or driving recklessly to get out of a dangerous situation. Another ethical issue is jobs becoming obsolete. Many companies have talked about eliminating the human when driving cars in industry settings. An example of this would be UPS or FedEx. Many times with these companies, we see that they are driving long distances to deliver packages. Ideally, the human would be replaced by the autonomous vehicle, and the autonomous vehicle would make the mundane flights of travel, eliminating that job for the human. So where are we headed? In 2006, we had passive autonomous drivers. From now to 2019, we have limited driver substitution. Phase 3 will begin in 2018 to 2022, where complete autonomous capability will take over. In the next 2 decades, we will see 100% autonomous capability. This is when on the road we will only see cars that are having vehicle-to-vehicle communication. The human will be completely taken out of this. This is a projected timeline and is subject to change. Perfecting the technology. The hardware is not the hurdle. Most of the technology used in autonomous vehicles is already created in today's society and being prototyped and tested. The hardware seems to already be in place here, so it looks to be that the development of the software will be the greatest development. Autonomous vehicles use incredibly sophisticated algorithms to interpret the sensory input. Sensory input being the car's surroundings, anticipating upcoming events, and predicting reactions. The increase in sophisticated software is needed in order to achieve full autonomy in these vehicles. Once full autonomy is reached, the world of autonomous vehicles will continually advance. The advantages and obstacles need to be weighed in, and us, as humans, need to be open-minded and ready for the significant changes in technology today.